Hello everyone, my name is Anton Boyko and today I would like to talk to you about the infrastructure monitoring and how to do that from requirements to tool, not the other way around. You can see my email here if you will have any further questions related to this presentation, or you would like to talk about something like cloud computing or IT in general. Feel free to drop me an email. I always try to reply to all the emails that I receive through this mail address. So let's actually get back to our topic. But before we start, I would like to actually tell you a small but still true story from my experience. So we're talking about monitoring today, and the story is more like a question how you will actually understand that your application is working. Okay, back in the 90s, there used to be a very popular way of doing monitoring for your app. We call it phone-based monitoring. So in case my app is not working, my users will just pick up the phone and they will just call me directly. As you can understand, nowadays that is not an option at all, but I just put it here as an icebreaker. Another option how you can monitor your app, or at least that's what I've heard from the engineers from different companies, is that they will monitor the CPU load, for example, and then if CPU will go above 90%, they may start the investigation. But technically that actually gives you nothing, because if CPU went above 90%, what that mean? It may mean that you are lack of resources, but additionally it may mean that you are the ninja in terms of planning your capacity for your application. It may mean that you plan your capacity exactly to that sweet spot where you have only small tiny amount of either under provision or over provision for your compute resources. So that's also not the best way how you can monitor your app. Another one can be that, okay, we will stream all the logs to the ELK stack. Yeah, that's a very popular thing, but for example, currently I'm working in a company called Voltec, and even the relatively small websites that we are doing can generate more than 1 gigs of raw logs per day. So those applications, they are really chatty. And in case you will have an issue, so good luck trying to analyze that amount of data. If your project is bigger than the average website, then technically the problem will be bigger, much bigger as well. So this is also a good option, but definitely not the best and not the proper way how you should do that. Another one may be we will ping our application with web pings, and we will use the solutions like Pingdom, for example. That's another interesting option, and technically that will help you to mimic the behavior of the end users, but still, what exactly you will ping with Pingdom? Will you ping, for example, the main application, the main website page, or you will ping, I don't know, some dedicated health check endpoint? How you can make sure that with that one ping, which can end up with either HTTP 200 or some other status code, you will have a decent level of understanding what is actually happening within your system. Another one, and this is quite popular nowadays, is that we will monitor our application with Prometheus, and then we will display all the dashboards in Grafana. This is actually a good one, but as an architect, what I want to say here, basically a single response to all those different options, is that please stop doing how before what. So when you're doing monitoring, it's very important to understand what exactly you want to monitor, and only after that switch to how we will do that. So basically, if you were following my presentations all across the internet, across different conferences, you may see this slide, but anyway, I still believe that this is the powerful one, so I will go with that one. The DevOps, the three stages of the conversation. Let's say that you want to change something, and let's say that you want to do the monitoring in a proper way. Start with the requirements and then basically go to the selection of tools and implementing those tools. So the first stage that you need to handle is the people stage. So you need to create that common ground. You need to explain to all your team members why this is important and how they can contribute and how they can benefit from that afterwards. The next one, you need to define all your processes. So basically, what exactly you will monitor, which metrics you will collect, how you will react to those metrics, how you will use them for troubleshooting, and so on and so forth. And only after that, only on the third stage, we can talk about the exact products, the exact tools, the exact implementation options, but only after we talk to the people and only after we define all our processes. So before we will get any further, today I would like to also scope a bit my presentation, because in general, when we are talking about monitoring is a very vast area and it will be impossible to cover everything just in one speech. So that is why today we will talk only about a tiny small part of it, which is based on real life experience, of course, and which is partially based on the transformation that we are currently running within the Valtech company, within the cloud engineering department. So I will talk about the monitoring, which is related to the infrastructure monitoring, not application monitoring. I will focus a lot on the performance part of it, so how we can monitor and how we can make sure that our infrastructure is performing well. And also I will talk a bit about the capacity planning and the way how we can again monitor that the amount of resources that we provisioned right now is basically enough. We don't have over provision, we don't have under provision, we provision the exact same amount that we need to handle the load that we have right now. So let's talk about the first stage. Let's talk about the people. So for the people, as I was saying, it's very important to create that common ground. How we did that? So first of all, we need to understand that there are two things: monitoring and observability. When we talk about monitoring is the process how we observe and check the progress of quality of something, okay? And observability, this is another important area. Observability is actually a quality attribute, and observability shows us how well we can understand what is happening within the system from the signals that that system exposes outside it. So this is a very important part, and why I want to highlight that and emphasize that again is because as an architect, when you are designing your application, it's extremely crucial, extremely important to think about the observability on a design stage. If your system has a decent level of observability, then configuring the monitoring for that system will be as easy as walk in a park. And for me, when I'm talking about the decent monitoring solution, for me it works like an infinite mirror. So I start on a high level, and then I'm basically narrowing down, I'm kind of diving deep into that exact area where I may or may not have an issue. So this is how I see that. This is the ideal monitoring, at least for me, at least in my understanding. It's also important to know that when we're talking about monitoring, it can be the white box monitoring, so we can monitor the system internals, and this is mostly suitable for the infrastructure monitoring that we are talking about today, or we can do the black box monitoring when we're basically mimicking the behavior of the end user, and of course it's a bit more suitable for the application monitoring. So today, as I was saying, we will be focusing more about the white box part of it. So another important thing is that, okay, we understand that we will monitor our infrastructure, but then It's also important to know from the people perspective that there are different types of measurements, and it's important to create that terminology so everyone on the team will speak the same language. So when we're talking about types of measurements, I would like to highlight three of them here. So that's the metrics, the events, and the diagnostics. And the idea here is that when we're talking about metrics, that's basically metrics like the exact load of CPU, the exact consumption of RAM, and so on and so forth. When we're talking about diagnostics, it's more about the logs that we store, and somewhere in between we do have our events. If you remember, like a minute ago, I was talking about the infinite mirror, and this is the exact case here. So I always start with my metrics, I work with them on a high level, then I dive deeper to my events, and only when I located the exact area of potential problem, only after that I will basically start looking at my diagnostics. So I was saying that my system can generate, for example, even like a small scale system can generate 1 gig of logs per day. And I don't really like to, go through the whole gigabyte of logs trying to find something really interesting there. I will start with the metrics to identify only a part of all those logs that may be interested for me. So for example, I would like to spend 5 minutes or like 10 minutes working with the metrics to narrow down my attention from 1 gigabyte to 100 megabytes of data, and then I can go to the diagnostics. So this is also an important in terms of way of working. And when we're talking about metrics, it's also important to understand that what can qualify as a metric should be able to answer all those questions that I have here. So for example, for each and every metric, you need to be able to specify what the value of this metric is. Additionally, how it was sampled. Additionally, is it the exact metric or it's already an aggregated value? Also, what is the frequency of this metric? Is it a metric that we were taking once per minute, once per second, and so on and so forth? What time is it from? And also, what does it mean? It may sound really simple, but anyway, what I was also seeing in a lot of different teams, in a lot of different projects, is that for example, when I asked those folks how you configure your monitoring solution, they were saying, oh, we're basically gathering a bunch of metrics. We're gathering the CPU load, the RAM load, and so on and so forth. And I was like, okay, but let's say now you have all that data, how you work with that data. So how you process it. Let's say that I have a graph, I have a chart, and on that chart, for example, one line went up, the other line went down. So what does it mean? And you will be surprised actually how small the percentage of the teams actually who can really explain me, as a matter of fact, those very simple things about their application and about their monitoring solution. So those, as I was saying, may look really simple and straightforward, but please at least try to answer all those questions when you will be thinking about your monitoring solution for your project. The next one is about the process. Okay, so how we will treat basically the monitoring of our infrastructure, what will be the process. Why this is important, and again, I will take Vaultek as an example, why it's important for Vaultek, because one of the offers that we're offering to our clients is a 24/7 support. When we're talking about 24/7 support, Vaultek has a lot of different offices all around the world. We have our offices in Asia, in Europe, and in North and South America. So the thing is that we don't need basically to keep one team somewhere like here in Eastern Europe or basically any other country. We don't need to have one team who will work around the clock. We are basically we can easily shift that responsibility to the other teams that are located in different regions, different time zones, and that is why have a common understanding, and that is why have a common process is crucial for our success. So when we're talking about process, again, here I would like to highlight only that one process that is related to the infrastructure and performance and capacity, which called the use model, or also use method or use methodology. You can actually Google all of those keywords, and at the end of the day you will be able to find the information about this monitoring model, and this monitoring model stands for the utilization, saturation, and errors. So this is what use stands for. The utilization is the average time that resource was busy servicing work. So in terms of the CPU, for example, that can be the CPU load in percent. Okay, so then the saturation. The saturation is that amount of work that was queued but not serviced. So again, in case of the CPU, that can be the CPU queue, or maybe a bit better analogy, if we talk about, let's say, the disk. We all know that when we are working with the hard drives, we do have a thing which called the disk queue. Okay, so that would basically mean that we are trying to put some load, we're trying to either write or read some data from the disk, but we are unable to do that, and our tasks are basically queued. And last but not least, the errors, which is pretty much self-explanatory. And then what you're basically doing, you are defining your resources, and as you can see, the author of this methodology suggests that we will define our resources as a components, as a functional components of physical servers. So you can define it as a CPU, as RAM, disk, network adapter, and so on and so forth. And for each of those resources, you will measure the current utilization, saturation, and errors over time. And then basically we'll be able to use all that data to identify, do you have any performance issues, or do you have any issues with your capacity of your infrastructure. One of the important statements here is that basically the reason why you gather all those is that it should allow you actually to do that transition really fast from unknown unknowns to known unknowns. In case you have an issue with the performance, in case you have a performance bottleneck, it's very important to understand actually where exactly do you have it. Because for the end users, if we're talking about web applications, websites, and so on and so forth, for the end users, what they will see that your pages are basically take forever to open. Okay, it can take, I don't know, like 5, 10, 20 seconds for a page on your website to open. And you may not really understand exactly, as I was saying, which exact resource caused that bottleneck, so that is why it's very important to make this transition. Even if your CPU seems to be loaded to 100%, still you need to measure the saturation additionally, because only with the saturation you will be able to understand, okay, this resource is currently working on 100% of each capacity, but do we need more or not? The saturation value will show you that. Do you need more or not? And if we can rephrase that and use the words of Sir Arthur Conan Doyle, then the statement will be the following: when you have eliminated all the impossible, whatever remains, however improbable, must be the truth. So this is another important actually idea and important thing about the use methodology, is that of course when you are doing the troubleshooting, especially when you're doing the performance troubleshooting for your infrastructure or for your application, actually it's always hard to understand basically where you should start and how you should proceed. But with that use model, you need to spend only 20% of your time to eliminate 80% of the possible reasons why you may have this issue. So this is the big idea here. So you're starting with something super simple and you're trying just to narrow it down, and you're just trying to say, okay, we check the CPU is fine. Okay, we check the network adapter is fine. So that means that if we have a performance issue, that's definitely not the CPU, not the network adapter. And this is actually the way how we are working, and over the years I found that a really kind of, useful way of working, in a way that you will just basically discard those options, or like you will discard those root causes that are not really applicable for your case right here, right now. So now let's go with the final stage here with the products, and for the products we will allow you to bring your own tool. The reason for that is, as I was saying, as a Valtech, we do have a lot of different projects all over the world, and for each and every client we may have different environments. For example, one client may be hosted on Azure, another one may be hosted on AWS, and the third one may be hosted on GCP. Someone may be hosted on premise, and then additionally there may be already some tools that client is already using within his environment to basically monitor some other applications. So we need to kind of integrate our ways of working. We need to integrate our 24/7 support into that client business environment. So that is why we don't care really a lot about the tools, but we care a lot about the way of working and the processes that I was talking about before. And on that part, let's go to the demo, and I will show you how we're working with the tools specifically for the Azure Cloud. The demo number 1 today will be about Azure VMs, and also that will be about CPU utilization and saturation. As you can see, I'm here on Azure portal, and I do have a test VM which I called Boyko Demo 01, and I also opened the Azure Monitor metrics. The important part here is on this chart that we have on top, I have one metric. This is the percentage CPU. This is basically current CPU utilization. I have the same metric in two different aggregations, max and average, and I was able to collect that metric from the Azure itself, from the virtualization host itself. Additionally, on this chart below, what I have here, I do have my CPU saturation, and I do have that CPU saturation as an system processor queue length metric that was exposed from the guest operational system through a specific plugin that you need to install to your VM. That was basically exposed, and now I can see it here in Azure Monitor as well. So what I would like to do together with you on this one, I would like to show you basically how it differs, what kind of different patterns we have here, and how we can use those both basically utilization and saturation to understand how efficiently we plan the capacity of our computer source here. Let's start at the beginning. At this data point here, and each data point on both charts represents 1 minute. So on this data point here, as you can see, we have a queue length of 1, which is quite okay basically, and we have the CPU utilization around 2 or 3%. Then if we will move a bit more forward, for example to this data point, we can see that the saturation suddenly increased. It spikes to 39 items in a queue, and the utilization is still only on 20% at max. And this is actually quite okay. If you have a sudden spike, and then, as you can basically hear on our example, and then at the next data point the queue length was reduced from 39 to 8, that basically means that you can process those tasks in a queue faster, that someone else is basically putting them there. Okay, so the utilization here is around 90% or more, which is okay, but again, because the queue lengths decreased, that means that we actually have a good capacity and we are able to process those tasks faster than someone is queuing them. Okay, so despite we're having 90, as I was saying, more than 90 even percent of the utilization here, it's still okay. We're still maintaining a good capacity and good performance on this one. Then if we can check, for example, the next area here, then that was literally the same picture. So at first we had a spike on saturation, which was 19, then we had a spike on the utilization, and at max we reach almost 80% of CPU utilization, but then the queue lengths went down. So again, we were able to process those tasks faster. But let's take a look at this particular data point here. Okay, so at this point the queue length was 10, and the next data point, the queue length was 11. That basically means that in 1 minute we were unable to process all the tasks that were in a queue, and even one extra task appeared. And the utilization level at this time was almost 100% at max. At this point it was 83%, then it went up again to more than 90%. So this one actually, when your saturation level stays on a flat line, basically not changing, like here it was 10, then next time it was 11, that basically means that you are more or less operating at your max capacity. If I will put a bit more load, the system will be unable to keep up. And this is actually what was happening here. So if you will see here, the queue length was 15 and the utilization was around 100%. And then the next time queue length was 22 and utilization stays again almost at 100%. The next time the queue length was 23 and the next one even 28 and utilization stayed again around 99% at max. So if you will take a look only at the graph on top, what you will see that actually 3 times, okay, this is the first one, this is the second one, and this is the third one, 3 times you had the utilization almost at the top level, almost at 100%. But technically, in the first case, that was totally okay, because that was just one spike. On the second case, it was okay-ish, because as I was saying, for a short period of time here we had the same queue length over the 2 data points, but on the third time we can clearly see that if I would have a faster CPU, if I would have more cores and so on and so forth, I will be able to actually keep up with the load much better. So that shows me that if my utilization stays at 100%, but the queue length keeps increasing, that means that here I have a case of under provision for my compute resources. I hope on this example you understand why measuring only the utilization is not good enough, why you need to measure the saturation as well. And with that, let's go to the next demo. Our demo number 2 for today is related to the Azure App Service, not to the VMs, and it is related to the CPU utilization and autoscale. So here we are again on Azure portal, and as you can see, we are again within the Azure Monitor dashboards, but the trick here is that now we are working on a different level of abstraction. Before that we were working with the VM, and now we're working with the PaaS level of service. So that basically means that we don't have the full control over the underlying infrastructure, and we also don't have the full visibility on the underlying infrastructure. That basically means that what I can get from my Azure App Service, I can get only the CPU utilization. And as you can see here, again, I'm basically using the same metric, CPU percentage, into aggregations, max and average. But if I will take a look at this chart, again, I can assume that probably here, when it was like a literally flat line, maybe here I was kind of under provisioned, and potentially if I will have something more on that one, I mean like more CPU again, or like more cores or more powerful CPU, then I will be able to process my requests faster. But unfortunately, if we want to follow the use model, then for Azure App Services, for this particular resource, for the CPU, we cannot do that. But still, it doesn't mean that you should not use Azure Web Apps. It just means that you need to treat your load a bit differently, and you need to basically find your way how you can still work with that, but a bit differently. The thing is that when you are working with the VM is by default the stateful, let's say, compute resource. It has the CPU, RAM, hard disk, and so on and so forth. But when you are working with the app service as a compute resource, it's stateless. Of course, you do have a persistent file storage for your Azure App Service, but that persistent file storage is a remote file storage. That basically means that because your compute layer is stateless, you can easily scale it out. So let's see how it's done. Let me open this guy here, and currently I'm not actually working with my web app or with my app service. I'm working with my app service plan, because app service plan represents the compute resources underneath the logical app service itself. So I will go with the scale out. And what I can do here, I can switch to custom auto scale, and here I can define my auto scaling rules. So let me just add one rule here, and I will show you how you can do that. So that will be your first rule, and then what can be the criteria? The criteria, for example, can be the CPU percentage, and over the time we will aggregate that as average CPU percentage. Okay, then currently we have only one instance, but if we will have more than one instances by default for this app service plan, then technically we can even choose to which instances this rule will apply, or to be more precise, from which instances we will collect those metrics and then use them here in our auto-scaling rule. So you can see that the current average CPU load is around 2.5%, which basically nothing. Okay, so what we can do next, we can define a condition. So let's say that if it's greater than, by default it suggests 70%, but let's use 60, just because again my experience shows that it will be more beneficial to upscale faster, but then basically downscale if you don't need those resources. That will help you to introduce a more decent performance. But as you all understand, here it's also all about the balance. You will put more resources, you will have better performance, you will need to pay more for your infrastructure. So always pay attention to that, and that decision needs to be made for each and every project individually. So then the duration in minutes, by default here we have 10. What that means? It means that the auto-scaling engine will monitor the load for 10 minutes, and if for the 10 consecutive minutes the average load for each and every minute, the average CPU load for each and every minute will be 60% or more, or technically only more than 60%, then that rule will be triggered. Okay, what will happen here? We will need to increase the amount of basically servers in this cluster, the amount of instances of this app service plan by 1, but I would actually suggest to increase them by 2. And then we have a cooldown in minutes. Here it's 5. That will basically mean that as soon as this rule was triggered, it will be disabled for 5 minutes after that. So we will basically give this 5 minutes to our application, first of all, to warm up, and additionally we will give that 5 minutes basically to the load balancer to redistribute the load across all the other nodes, all the new nodes that we now have in our cluster. So I can add this rule here. That will be the upscale rule, or let's say not the upscale technically, that will be the rule for scaling out. And additionally, we also need to define a rule for scaling back in. As soon as we will process all the load, we need to scale that back in, deprovision all the resources that we are not using anymore. So here again, I will use the CPU, I will use average across all instances, but now I will say that if it's less than 30% over the last 10 minutes, as you can see here, I will decrease count by 1. And then I will again take a 5 minutes cooldown. I will add this rule here. So how it will work now? As soon as I will start basically having that load, my scale out rule will create kind of two new instances as soon as the average CPU load will go for more than 60%. Then as soon as the load will be less than 30%, on average across all the nodes in the cluster, it will start to removing those nodes one by one. So in that case, I'm deliberately kind of accepting that at some point I will definitely go with over provisioning, and at some point I will always provision more and more resources, even more that I may need to handle that load. But again, in this case, I'm optimizing not on a budget, I'm optimizing on a performance. And this scenario is also viable in a case if your application needs to take quite a long time to warm itself up. So let's say if your application needs something like, I don't know, like 10 or 20 minutes just to warm up all the caches, still it's possible to configure the autoscaler for that kind of an application. If you're using the Windows-based app service, there is a way how you can configure with your web config basically the default behavior for the load balancer to first of all let the application warm up, and only after that start serving traffic to that node. Then basically that will be the recommended way to proceed. As I was saying, if your application takes a long time to warm up, create more instances, you always will be able to remove them if they are not needed with this configuration like I showed you here on this example. And on that one, let's go to our final demo for today. For the third demo, I would like to show you that the use methodology or use method or use module, which stands for utilization, saturation, and errors, technically can be applied not only to the infrastructure, but to anything that you can define as a resource. And on this example, as you can see, we're back to Azure portal. Now we're working with our app services. On previous demo, we were working with app service plan. And for the app services, I'm again within the Azure monitor, and here I'm basically showing you 3 different metrics, but all of them are around the same resource. Here, in this case, I defined my resource on the application level, and my resource is basically my HTTP server. And the utilization, as you can see in my case, that's just the sum of all resources that were processed by my application server over time. The next one is the saturation for the same server. The saturation is the amount of requests that are in a queue. And the next one, the errors, and this is actually quite tricky because on 2 previous demos we didn't talk about errors at all. We have them only here, as a matter of fact. But anyway, so the errors in that case will be among all those requests that were processed, how many of them actually failed with an error. And you can see this chart here, and you can see that overall over this time period I processed a little bit more than 8,000 requests in total. My max level of application queue was 0, so that basically means that when I was processing all those requests I always had the enough level of capacity. Okay, so the queue was always 0, slash was always 0, and then some of the requests failed with errors, so on total 141 requests failed with errors, and for me that basically means that I need to go and I need to check what was happening with the entire system during that time when those requests were failing. So for example, I can actually zoom in on this guy here, and you will see that here at some point I was able to process 45 requests and 45 of them basically failed. So on this demo I show you how and why you should also consider of basically measuring the amount of errors for that resource, and this is the perfect indication for me that it's not only something that is really bad with my performance, but it's something that is really bad with my application, because the rate of the errors at this particular data point was 100%. It's not always that you can basically collect all those 3 metrics for each and every resource that you will define, but anyway, the methodology was originally designed for the physical bare metal servers. Now we're applying it to the cloud, and it can and it should be applied to the cloud, to the virtual resources, but you need to be a bit crafty. And also, I would like to say a few words in conclusion. So first of all, I've talked about that a lot of times today during this session, but still I do believe that this is extremely important. You always need to keep the balance between the speed and the precision of your measurements. So if you want to take some measurements, let's say very frequently, for example, like once per second or something like that, you need to accept that you will need to sacrifice on the precision. So choose this balance wisely. The next one is basically, let's say that your monitoring solution was not ideal, or you don't have any monitoring solution at all for your project right now, so you decided, okay, let's go and implement something. Then you will need to be able to assess somehow, or let's say measure the overall success of your implementation. And one of the ways how you can do that is by metric, the overall metric which called MTTD. MTTD stands for mean time to detect. In other words, how long the issue was there before you became aware of it. And if we will take a look on a regular, let's say, flow of events, you have an incident, and then after some time that incident was detected by a tool, so you get the notification, and then you started your investigation, and only when you identify what was the root cause of the problem, you proceed with the mitigation and fix it. Okay, so if we're talking about MTTD, the decent monitoring solution, first of all, it should help you to reduce this gap between the incident actually happened and between the notification that you received on your email, phone, or whatever. Additionally, MTTD should help you to reduce the investigation time, because if you don't have any monitoring at all, you can again be notified by a solution like Pingdom, which I was talking about at the beginning of my presentation. You can be notified that your website, for example, is inaccessible, but then where you will start? how you will start your investigation if you don't have any logs, you don't have any metrics, you don't have anything. So a good and decent monitoring solution will help you, first of all, to reduce the gap between the incident and notification, and also it should be able to reduce the time that you need to spend for the investigation. Additionally, the other metric called MTTR, which stands for mean time to repair, the metric which more or less looks similar to the previous one. So yeah, this is the amount of time required to repair the system and restore its functionality. So when you will basically start measuring those two metrics, the one important thing is that you always need to start measuring them in advance before you proceed with your implementation. The reason why you need to measure them in the first place is that you can't improve what you don't measure. So if you don't know what your MTTD and MTTR were before you started your improvement or before you started your new implementation, then if you will measure them only afterwards, how you can say actually what was the exact level of improvement? You don't. And also, as I was saying, if your monitoring tool works as expected, it will help you to keep the MTTD and MTTR actually low. And for your managers, you can easily show this kind of a diagram. I was already talking about that. So the failure occurs, then you need to wait some time until the tool will detect it and you will get notified. Then you also need to spend some time to diagnose what was the root cause of it, then the repair time, the testing, and return to the operation. So with a good monitoring tool, it will help you actually to reduce the lead time on each and every area that you have here on this diagram. And another one, a very, very important general statement. Today we were talking about the infrastructure monitoring, and therefore there is a thing called infrastructure SLA. But infrastructure SLA is not equal to the application SLA. Those are two totally different things. Let me give you just a simple example. Let's say that your infrastructure provider will guarantee you that for the specific period of time, the total infrastructure downtime will be no more than 10 minutes. Okay, but let's say that also your application needs to take 1 minute after the infrastructure failure to warm itself up. That basically means that if you have 10 minutes of downtime in one chunk, then the overall application downtime will be 11 minutes. Okay, but your infrastructure provider promised you no more than 10 minutes, but he didn't specify exactly how many times it can happen. So if you have 10 chunks by 1 minute each for the infrastructure downtime, then, because as I was saying before, your application may take 1 minute to warm itself up, so the total application downtime will be 20 minutes. Okay, so 11 minutes versus 20 minutes. This is the very important part. Please don't treat infrastructure SLA and application SLA as the same thing. So now I'm done with my speech, I'm done with my session, and I invite all of you to join me in a chat, and if you will have any questions, feel free to ask them there, or as I was saying, you can also write to my email and I will try to reply you as soon as possible.